Today I'm going to show you how to solve a rational inequality. This actually comes from the homework problem, so we've already done this in the notes, but let me show you another example of what this looks like. So a rational inequality, there's kind of a lot that's going on in this one. We want to solve this just like we were solving an equation. So you still got to go through that same process. You need to factor the denominator if it can be factored, which in this case it can. So the x squared minus x becomes x times x minus 1. You then need to figure out what your common denominator is once everything's factored. And I have two different factors. I have an x minus 1, I have an x, another x minus 1, and another x. So you don't need to repeat anything that's happening in the denominators. You only need one of each of the things that are being multiplied. So even though there's two x's, they're in different denominators. So my common denominator would be x, and then I would also need an x minus 1. So everything gets multiplied by that common denominator. So I'll show my work. The first one is 1 over x minus 1. That gets multiplied by x times x minus 1. Less than or equal to 5 over x times x minus 1. And that gets multiplied by that common denominator. And then that's minus 1 over x times, once again, that common denominator of x times x minus 1. The reason we do that is so that things cancel. So I'm going to change color so you can see what's canceling. So this x minus 1, this factor is going to cancel with this factor, which leaves you with just 1 times x is x. This x minus 1 cancels with this x minus 1. Sorry about that. That x cancels with that one. And so now you're just left with 5 times 1, which is 5. And then on the last one, this x cancels with this x, so that's minus, and it's minus this whole thing. So it's minus this quantity of 1 times x minus 1, which 1 times x minus 1 is just x minus 1. But you need to make sure you're subtracting that quantity. So now we solve. X is less than or equal to 5 minus x plus 1. So if you add the x to the other side, that's 2x is less than or equal to 6. And so we get x is less than or equal to 3. Now, with an equation, we would have x equals 3. We would check against our restrictions, and we would be done. Our restrictions in this case are x cannot equal 0 and x cannot equal 1. Remember, that comes from your denominator. What values in your denominator what values of x in your denominator make it 0. So we actually have kind of 3 things that we need to look at. And so what I want to do is zoom out a little bit here, maybe. Alright, and so what we're going to do is we're going to create this number line. This is your x-axis. And on the x-axis, we know there was a solution of 3, okay, where it crosses the x-axis. We also know that at 1, there's a restriction. There's a vertical asymptote there. And then at 0, the same thing. So there's these restrictions on the x-axis. And so what we now have to do is we have 4 total sections. In each of these sections, we have to test a point. So anything less than 0. So let's just pick x equals negative 1. Alright? You have to plug that back into the original problem and see if that is a true or false statement. And then we can, in this section, and anything between 0 and 1. So let's do 1/2. Anything between 1 and 3, we'll do 2. And anything larger than 3, we'll do 4. So you have to sit here and plug all these values back in and see whether it is a true or false statement. Okay, I'll do a couple, and then I'll let you kind of do the rest. But if I plug in negative 1, and you definitely need room here, so this would be 1 over negative 1 minus 1. This, you're trying to figure out, is it less than or equal to 5 over negative 1 squared minus negative 1 minus 1 over negative 1. So 1 divided by negative 2 would be negative 1/2 is less than or equal to, and then you got to figure this out. Negative 1 squared is 1 minus negative 1 is 1, so 1 plus 1 is 2, so that's 5/2, and then negative 1 over negative 1 is plus 1, so is negative 1/2 less than or equal to 1 plus 5/2, which would be 7/2 or 3.5? Well, yes, a negative is definitely less than a positive, so this would be a true part of the graph. Now at 0, there's a restriction, okay, because that's one of our restrictions. At 1, there's a restriction. But at 3, because it was less than or equal to 3, it's filled in. So we're going to sit here and test points. So this whole thing here that I just did was just for this section right here. Okay, so I tested a point, it was true, so that's part of my solution. And then you have to go through and do this 3 more times. And once again, I'll let you do that. I'll show you what the answer is. The next 1/2 that you plug in will be false. The next one will be true. And then the last one will be false. And a lot of times you'll see this pattern, but it doesn't work all the time, so you got to be careful. So where I highlight is where it's true. And then that's going to be your solution. So when you go to write your solution, you want to write all the values that were true. And so we'll say from negative infinity to 0, so all values less than 0, or values that were greater than 1 but less than or equal to 3. So here's your final answer. That's what we would be looking for. Alright, I hope that helps and kind of clarifies some of the rational inequality stuff and kind of the expectation in terms of when you get to done with the solving, you do have to go back, plug it into that number line, the restrictions and the solution. Alright, so you could have 3 sections. This one had 4 sections. It all depends on how many solutions you have and how many restrictions you have as to how many sections you actually have to go through and test. Alright, if you have questions on this, you can ask me in class. Thanks.